Hello dear students, I am Abhijit Gavas and I am going to start a new chapter today, that is system of particles and rotational motion. Now if you look at this topic is a pure application of the previous topic which you have studied so far. It might be motion in straight line, motion in a plane, work power energy and laws of motion. So this topic is a whole application of the topics which you have studied so far. Okay, now this topic starts with a concept of rigid body. Now before we start actual topic, here in this topic we are actually going to study the rotational effects of the body. In this topic we are going to study the concept of rigid body. We are going to see what are the different kinds of motion a rigid body undergoes. Then we are going to study the center of mass concept, then followed by torque, angular momentum, and then we'll conclude this topic with theorem of perpendicular and parallel axis. Okay, so it starts, if I look at the weightage, minimum 8 to maximum 10 marks you can expect in the board exam from this topic. Okay, so it starts with a rigid body. Now the name itself suggests what is a rigid body. A body whose shape and size does not change under the influence of any external force is called as a rigid body. Like if I write if a distance between any two internal points of a body remains fixed, or I would say remains constant, then that body is said to be a rigid body. Like if I take any body, particularly rigid body will be any solid body. Not all the solids, because again we further classified solids into plasticity and elasticity, but most of these solids what you see are all, if we take an example of this marker is also a rigid body. Let us see how exactly it is a rigid body. Like if I take any two internal points of this body, let me name it as A and B, and I am going to apply certain amount of force to this body. Assume that body has traveled certain distance and it had come to this point. Now if I measure this distance before the application of the force and after the application of the force, this distance will remain same. Okay, and when the distance between any two consecutive particles or maybe any internal particles remains same, then that body is said to be a rigid body. Okay, to tell you in the simple words, the shape and size of the body does not change under the application of any external force, or maybe when the body is in motion. Okay, maybe it might be a solid disc or a solid cylinder, or for maybe this board is also a rigid body. Over a span of time, the distance between any two particles will remain always constant. Okay, so in this topic we are going to study in detail what exactly is rigid body and what are the different kinds of motion does the rigid body undergoes. So in exam, if they ask what is a rigid body, you have to just define it as if the distance between any two internal particles, if it remains same throughout the motion or maybe under the application of certain force, then that body is said to be a rigid body. The name itself is a rigid body, rigidity. Okay, it implies to the rigidity. Okay, so now rigid body can undergo two types of motion. First one is a translational motion, and the another one is a rotational motion. So rigid body will undergo two types of motion. One is a translational motion or another one is rotational motion. So before we start actually the rotational motion, we'll first study in detail what exactly is the translational motion. Now the translational motion is somewhat similar to your straight line motion, but not perfectly straight line motion. There is a hairline difference between a straight line motion and translational motion. No doubt it is one of those straight line motions, but let us see how it is different from your traditional straight line motion. Now if I take any body, if I draw any body, and if I take any 2 points within that body, A and B, okay, and I am going to apply certain force, and due to this force it has traveled certain distance A, B, and it has come here. Now how do you define a translational motion? before I explain you, I'll just write the definition. If the line drawn between any two internal points of a body, if it remains parallel to each other during motion, then that type of motion is known as translational motion. That type of motion is known as translational motion. Now let us understand. The line drawn between any two points. I am taking this body and I will draw an imaginary line. And I'll apply certain force, and due to that force the body underwent certain displacement. It is in motion. So, and we will call that motion as a translational motion. Now let us understand. The line drawn between any two internal points of a body, if it remains parallel to each other, look at this line. This is before motion and this is after motion. Look at those two lines. If these two lines remains parallel to each other throughout the motion, then that kind of motion is known as translational motion. Translational motion. Maybe the body might be traveled here also. Again, if I draw an imaginary line, that line is always parallel to this line. Are you understanding? So, definitely it is one kind of straight line motion. But what we are extra adding here, the line drawn between any two internal points, if it remains parallel to each other, then that is called as a translational motion. Are you understanding? Have you copied? Okay. So now further we are going to classify translational motion into two types of motions, because it is not always possible that body will travel in a straight line. Whenever a body is in motion, it may take left turn, right turn. As I told you, this is an application of the straight line as well as motion in plane topic. In motion in plane topic, we take two coordinates, x and y. Now, look two instances here. I'll subdivide here. Okay. Now this is certain body. I'll take those two internal points and I'll draw an imaginary line. So the body has traveled certain distance, and if I draw an imaginary line between any two points, maybe there might be a point here also. See, maybe certain point. If the body is extended, I may take a point x, y, whatever it is. I am just interested to take an imaginary line between any two points. Now, if I take an imaginary line during the motion, then this is called as a translational motion, because lines are parallel to each other. This type of translational motion is known as rectilinear motion. Rectilinear motion. Translational motion is divided into two parts. One is a rectilinear, the one you are seeing here, and another one is curvilinear. Curvilinear. What if the body is not traveling in a straight line? Suppose I'll take any body, any random shape. Let us draw. Okay, just a minute. Any shape you can draw. Let me draw a triangle. Okay, the triangle, I'll take A and B. The triangle came here, A and B, and the triangle again came back to this position, A and B. Now see here, is body actually traveling in a straight line? Rectilinear, understand, rectilinear means in a straight line. Light undergoes rectilinear propagation. What does it mean? Light travels in a straight line. Okay. Now see here, if I draw a parallel line here, and maybe a parallel line. When body was somewhere here, here parallel line, here, and the body is traveling again in a straight line. If during the motion it is not following a straight path, but the lines still they are parallel to each other, then definitely it is also one kind of translational motion, but it is categorized as curvilinear motion. Curvilinear motion, because it is taking a curve. This is called as what? A curvilinear motion. Okay. So we started with translational motion. Lines should be parallel to each other. Then again we subcategorize into two parts: rectilinear motion and curvilinear motion. If the body would be traveling certain zigzag path, whatever it is, but still the lines are parallel to each other, then I call it as a translational motion. First you take a translational motion, then later you decide whether it is a rectilinear or curvilinear. If it is traveling in a straight line, categorize them under rectilinear. If it is taking zigzag path or any curve path, then categorize them into a curvilinear motion. Are you understanding? Yes. Then moving forward, we will study the next important type of motion, that is rotational motion. And on this topic, the rotational motion, it is all about the rotational motion only. So you have to understand this kind of motion very much effectively. Okay. Now, all of you know the rotational motion. Okay, if I give an example, Earth rotates about its axis as well as Earth revolves around the sun. So there is a difference between the rotation and revolution. Rotation means rotating about its own axis. Okay, so rotational motion. Rotational motion. Rotational motion is a motion in which all the particles, I'll focus on internal particles, is a motion in which all the particles of a body moves along a circular path, moves along a circular path about a fixed axis. About a fixed axis. Okay. Now don't confuse yourself with the rotational motion and circular motion. They are totally a different kinds of motion. No doubt there are quite similarity between them, but there are certain difference that you should know. Okay. Rotational motion is a motion in which all the particles rotates or they follow a circular path about a fixed axis. Here this word is very important, about a fixed axis. Like suppose if I have a body, let me take the triangle only. I have point A and point B. This is one point and this is one point. If I pivot this body, what is meaning of pivotation? Means I just hold one end of that body and I apply the force. Pivotation means, are you understanding, right? Same with the door, right? Door is held at one corner. It is pivoted. So when you apply a force, door will follow a rotational path. Are you understanding? So I have pivoted this body with one end. Are you understanding? Now, if I apply a force on this body, what will happen? In the previous case, if this pivotation was not there, don't get confused by the word pivoted, okay? It's just one axis. It's a fixed axis. One end is fixed and you are applying the force. Imagine if this pivotation was not there. If you would apply the force, what would happen? Body would have gone in this direction, straight line. But now, if this body is pivoted with one of the end, then when you apply the force, the triangle, instead of coming here, it may follow a circular path. It may come in this path and this path. Are you understanding? Are you following my point? This B point, instead of being parallel, now it is following a circular path. This kind of motion is known as rotational motion. If I take any part, C would have gone here. If I take a point D here, D would have followed here. If I complete this path, I am going to get a circular path about this fixed axis. Such kind of motion is known as rotational motion. Now, how can you differentiate between translational motion and rotational motion? In translational motion, the lines were parallel to each other. But look at this rotational motion. The lines joining the imaginary line are not parallel to each other. It is following a circular path. Are you understanding? So, that is one difference. And one more difference is, in translational motion, all the particles were experiencing same velocity and same acceleration. Yes or no? If this is the body A, this is body B, this is body A point, these are two internal points. In translational motion, what is happening? this body had these fixed points and they were traveling a straight line, they were parallel to each other. So because of that, they were moving with same velocity as well as same acceleration. But here what is happening? The lines are not parallel, as well as particles are not moving with same acceleration as well as same velocity. See, suppose this is a marker. If I hold one end and if I apply the force in this direction, the marker, instead of going in straight line, it is following a circular path. It is rotating about this fixed axis. This is my fixed axis, and when I apply the force, it is moving. Now imagine the particle was here, another particle here, another particle here. Now this particle is traveling more distance. This particle is traveling a less distance, a smaller radius. So as a result, what is happening? They are not traveling with equal velocity because radius is different. This particle is encircling a larger circle with a big diameter. It has to travel more distance at same instant of time. So as a result, these particles are not traveling in a straight line. So this type of motion is known as rotational motion. Okay, this type of motion is known as rotational motion. I hope you understood. As we go deep into the subject, things will be quite clear. This is just an introductory class. So moving towards the third kind of motion, which is actually not part of your syllabus, but you should know this. It's a planar motion. It's a planar motion. In common language, they call it as pure rolling. Pure rolling you are going to study in the next the upcoming videos, okay? But let us have a little bit of introduction. Now planar motion is a combination of translational motion plus rotational motion. Translational motion and rotational motion. So planar motion is a combination of translational motion and rotational motion. Imagine this one example. There is a body in shape, circular shape, and this is a line joining these 2 points, A and B. Now this body is not rolling. What I do it, I just apply force and bring that body here. Just move them in a straight line. This is not a translational motion. Yes. Remember, it is not rolling, okay? It's not rolling. Now, second case, same body, A and B. Apply the force. Now, in this case, the body is rolling. So, once the body is rolling, definitely what would happen? This B point rolling, roll, karte, rolling, it might come here, the point A. Because this is center, this center will roll about itself if there was a point here. Are you understanding? Now this combination of both the motion is known as planar motion. Are you understanding? Translational motion plus rotational motion will give you rise to planar motion. Now if I take any particle from this point, see, it is tracing this path. If I take another path, this path, circular motion. All the particles are not traveling with equal velocity. But there is one special kind of particle, maybe at the center. This particle is not tracing a circular path. It is following a straight line. Can you see that? Can you see that? That there comes the concept of center of mass that we are going to study maybe in the next video. If time permits, we'll try to complete center of mass today itself. But let us see how it goes. Are you understanding? Yes. So here is something to do with the center of mass. So in every body there is one particle will actually follow one straight path, and that point is known as center of mass. So far whatever we have studied, F is equal to ma or P is equal to mv. When we take net force, okay, when we take net force or net momentum, which acceleration I am considering? Which acceleration I am considering? If you look closely, acceleration of every particle is different. Acceleration of every particle as well as velocity is different. So what this acceleration means? This acceleration actually I am taking off center of mass. This velocity I am taking off center of mass. Okay? Don't be amused with the word center of mass. Once we actually start the center of mass concept, then things will be quite clear. So right now you understand rigid body, two types of motion, translational motion, rotational motion, translational, two types, rectilinear and curvilinear. Then rotational. And then last kind of motion, that is a planar motion. A planar motion. Okay. Now, this topic, the rotational motion topic, is an extension of the motion in straight line as well as motion in plane topic. So there are certain similarities between straight line as well as rotational motion, and let us try to highlight those points, because once you are perfect with the straight line concepts, these things become very easy to understand. If you are not perfect with the terms which you have studied in a straight line, maybe in a plane topic or maybe in the laws of motion, then this topic becomes really difficult. So it is always convenient to make those topics perfectly and then study this topic, because this rotational motion and straight line motion are quite similar. In straight line, body is going in a straight line, but in rotational motion, same body is traveling in a circular path. So there might be certain similarities in that topic as well as in this topic. So let us try to relate those things. So we have studied a linear motion, and here we are going to study a rotational motion. Let us try to correlate them, how it is possible. Now, here we have a displacement, linear displacement. Then here we are going to take angular displacement. Here we are going to take what? Angular displacement. Suppose there is a rod fixed at one end. Okay, this point is pivoted, and there are point B, there is point C, there is point D, and so many points. Apply the force, circular path. Apply the force, circular path. Apply the force, circular path, and this might be the center. Are you understanding? Now, this body has underwent displacement, okay, with respect to this fixed axis. Yes or no? With respect to this fixed axis. I'll just draw one circle, okay, so that it will not confuse you. Okay, now see here. So if I take a rod, a point A here, it's a pivoted point, you apply the force, and the body will, if this is point D, it will follow a circular path. Let this be the center. Are you understanding? So it creates an angle here, theta. So whatever the particle was here, it has underwent this much displacement, that is S. That is a linear displacement. And if it has traveled this much distance in terms of angle, then that is called as angular displacement. How you define angular displacement? Theta equals to S by R, which is quite similar to your units and measurement topic, where we have studied a concept of plane angle. Plane angle is a ratio of arc length to the radius of the circle. Yes or no? Correct? Okay. Now here we have studied a concept of velocity. Yes or no? Shall I erase this? Okay. Try to imagine this diagram, okay, because every time I need to draw it, but I don't have that much space here. So here we have studied velocity. Here we are going to study angular velocity. Here we are going to study angular velocity. Are you understanding? Here we are going to study what? Angular velocity. Okay, where V is written as R omega. I hope you remember this equation from motion in plane topic. Then here you have studied a concept of acceleration, and here you are going to study a angular acceleration. Are you understanding? Here you have studied actually two types of acceleration, centripetal acceleration and tangential acceleration. Similarly here you are going to study angular acceleration. I hope you remember the concept in circular motion. What is angular acceleration and what is tangential acceleration? Okay, so here you have studied a linear force. Here you are going to study a torque. Okay, what is F is equal to ma here? Here what is tau equals to I alpha. So combine this. This T is a torque. Torque is also a force, but in which sense? In rotational motion. If the body is rotating under the influence of force, then I should not call it as force, but I'll call it as torque. Torque is a rotational force. F is a linear force. Ma, I alpha, mass into acceleration. Moment of inertia into angular acceleration. Moment of inertia into angular acceleration. So I can resemble here M. M is nothing but what? M is equal to I. And what is I? I is moment of inertia, which is given by I equals to mr square. Further we are going to study. Then here you have studied a concept of momentum, linear momentum. Is it not? mv. And here you are going to study a concept of angular momentum. Angular momentum, r cross p. R cross p, angular moment. Then here you have studied work done. What is work done? Force into displacement. Here also you are going to study work done, but in the rotational sense. Work done is what here? Torque into angular displacement. Then here you have studied kinetic energy, half mv square, and here you are going to study kinetic energy as half I omega square. So look here, these are all the terms what you have studied in a straight line. But here in this topic also you are going to study these all terms, but in which sense? In rotational sense, in terms of angular displacement, angular displacement, velocity, angular velocity, acceleration, angular acceleration. I hope you remember what is centripetal acceleration and what is tangential acceleration. Force, torque, momentum, angular momentum, work done, and kinetic energy. But remember these equations, right? Okay, I hope you have copied this. Then further moving towards some other equations, we'll first try to relate ourselves to this topic by connecting ourselves to the straight line as well as motion in plane topic. So in straight line you have studied the equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. V square is equal to u square plus 2as. Okay, just a minute. Now let us relate this also. What is v here? Omega u naught, omega naught plus alpha t in rotational. S is what? Displacement. Here will be angular displacement. Omega naught t plus half alpha t square. V square is omega square. U naught is omega square plus 2 alpha into theta. Got it? Fine. So now we'll study little bit of this those terms. Okay, like velocity. If we take velocity, if a body is revolving in a circular path, what is the direction of this velocity? It is always tangential to the circle. Yes or no? Velocity of a particle. And if it is pivoted at this point A, look at point B, point C, point D. Every particle will travel with different velocity. Yes or no? So linear velocity will be different for different particle. What is the reason? Because they are tracing a larger circular path at this point, smaller circular path at same instant of time. But what if I talk about angular velocity? What if I talk about angular velocity? Angular velocity will be same for all particles rotating in a circular path. Angular velocity will be same for all the particles rotating in a circular path. Please try to understand this if you can. Okay, there was a point. Okay, this is point A and this is point B. Okay, or maybe I'll take the point B here only. So A has traveled this much distance, B has traveled this much distance. So what is a theta for A? Theta only. What is the angle for B? Theta only. Are you understanding? At what time? In 1 second A is traveling from here to here. In 1 second B is traveling from here to here in 1 second. So in 1 second, what is the angular velocity of A? It is traveling 30 degree in 1 second. What about B? 30 degree in 1 second. So remember, omega always remains same for all the particles in a rotational motion. And what is the direction? See, again it's omega, it's a velocity, then it's a vector quantity. It should have a direction. Always remember, omega is always perpendicular to the circular path. You can use a right hand Calp's rule or right hand screw rule. You can also use it to get the direction of the omega. Omega is always perpendicular to the circular path. There was a point A here and there was a point B here, and this was the theta. Got it? Are you understanding? So you can use your right hand Calves rule. Right hand Calves rule. You can take a point A and B here. A and B, you can calves them. So the thumb gives you the direction of the velocity. The thumb gives you the direction of the velocity. Which velocity here? Angular velocity. So remember one thing ki angular velocity is always perpendicular to the circular motion. Angular velocity will be always perpendicular to the circular motion. Okay. So fine. So I hope you have understood this. So we'll stop it here only. So maybe in the next class we'll start the concept of center of mass, and we'll study what exactly is torque and angular momentum and these all concepts. So for today it's enough. Okay, we have started with a rigid body. What is a rigid body? If the distance between any two internal particles remains constant throughout the motion or under the application of the force, then that body is called as a rigid body. Rigid body can undergo two kinds of motion, translational motion and rotational motion. What is translational motion? If the line drawn between any two particles remains parallel to each other throughout the motion is called as translational motion. It will again possess two types of motion. One is curvilinear and one is rectilinear. Curvilinear, curved path; rectilinear, a straight path. Then we have studied rotational motion. What happens in rotational motion? Ki particles will rotate about a fixed axis, and that fixed axis is known as axis of rotation. That fixed axis is known as axis of rotation. Here no points are parallel to each other, and all the particles are traveling with different speeds as well as different accelerations. Obviously, if there is change in acceleration, there is definitely change in the speed, but in translational it does not happen so. When we combine these two motions, then we get a planar motion, which is a combination of translational motion and rotational motion. Then we have studied certain analogy between, we have tried to connect a linear motion with a rotational motion. Okay, now I'll give you three cases. Okay, I'll give you three questions, rather saying cases, three questions. Okay, and you should answer them in the comment sections. Okay, I expect you to answer into a comment sections. Okay, okay. So if I give three cases, you have to tell me what kind of motion it is. A ball rotates. Second, a ball does not rotates but follows but slides along a circular path. And third one is ball does not rotate. Okay, a ball slides along a straight path but does not rotate. I expect everyone to answer these questions. Okay, you should tell me what kind of motion is this. You should tell me what kind of motion is this, and you are going to tell me what kind of motion is this. First condition is ki ball rotates about its axis. You can add here, ball rotates about its axis. The ball does not rotate but slides along a circular path. So we have a ball which is not rotating but it is sliding a circular path. Okay, and third condition is ball slides along a straight path but does not rotate. I just leave that ball does not rotate but it slides along a straight path. Please answer these questions in the comment section. Okay, so thank you. We'll meet in the next video. Okay, we'll stop it here.